Hi. Is it just me and you again today?
Yep.
Exciting. Let's see what we can do. I wanted to continue discussion about slope, thoroughly exhaust that before we move ahead. It'll be interesting. We've gone at such a critical point in linear algebra. The whole, what angle does the line go at, you know? It's like 95% of the ball game. What's up, Sebastian? How's freshman year so far? Hey, Haley. Yeah? Okay. You like high school versus middle school? Oh, a lot. Oh, okay. Yeah? Well, good for you. Was middle school awful, or is high school just that much better?
No.
Oh, yeah? What was the worst part about middle school?
We did so much homework when we did that.
Yeah? Interesting, okay. Are you talking about math, or are you just talking about school? Really? More homework in middle school? Wild. Not just last year, but every year in middle school? Really? That's crazy to me. Haley, we gotta get together and do portfolio stuff. We can do it on Discord, but we gotta get together at some point and get that done. Just, I gotta see what you're doing. We gotta talk about it. Are you aware of all the stuff that you need to show me? Like all the stuff that I don't have the picture up on Google Classroom. I put it on Google Classroom right now. Gotta do it on my phone, that's why it's not up there. Here are the requirements for this week. Had to do with talking about lines, right? That's what we've been talking about. I took a picture of the board from when I wrote it on the wrote it on there. On Google Meets. Yeah, you're scheduled today at 2 o'clock. Sebastian, I might be a little late to that. Hopefully I won't be. I have a meeting at 1:48, which I did not have until this morning. So I'm sorry about that. That's just kind of the way it rolls sometimes. Okay. Hey, Camden. All right, so today, guys, let's do attendance real quick. I've only got one kid in class today. Kaylee said she'd be back. She checked in early. I think she's trying to figure out the new schedule. McDonald's, I don't see him. I see Camden. I don't see Leah or Mac yet. They'll just ring, though. I don't think McDonald's have missed today yet. Kaylee will be here, I'm sure. Alrighty. And this is kind of about what you're supposed to write about, Haley. The different parts of this, right? Oh, hey. So this number right here kind of serves where our pattern starts, right? So wherever we start, it's going to be 0, comma, whatever this b is. Let me zoom in a bit. Oh, that's very hard to see. Forget zooming in. Let's do this. AA. Right, so that's where our pattern starts. When x is 0, the y will be whatever b is. And that makes sense, right? Because if I plug in 0 for x, 0 times anything is nothing. And nothing plus b will be whatever b is, right? So our pattern starts there. What's up, Cameron? And then this right here, the m, right, which stands for slope, because French people, is really the relationship between x and y, how much they increase by, right? So slope is going to equal the rise over the run. In other words, right, it's going to tell us how much the y goes up and how much the x goes up, right? So there's our y number, there's our x number. Let's use green and red. I like green for the y number. So this is our rise. And this is our run. In other words, it's how much y goes up and how much x goes up. Another way to write that is to say not y, because remember, y is a number, right? It's not how much something's increasing by, it's just whatever the number happens to be at that point, right? So we call it delta y, and you'll learn about this in calculus eventually. I'm not going to make you, there's no quiz over this. I'm just saying that's what this means. Delta means change. Okay, it's a Greek letter, that's why it's a triangle. And for some reason, the Greeks thought triangle meant change, and so they said the change in y. How much this number changes, the y part, right? And then the run is how much the x changes, right? So it's delta x. Let me close the door. Right, when we change in one direction, it's how much we change in the other. That's what this is talking about, this letter right here. It deals with how much we're changing. So if I said this is our pattern, and I said, well, the y goes up by 3 every time the x goes up by 2, you would know that the slope of this pattern would have to be 3 over 2, right? For this example. So where I start is the b, and how much I go up on each side is our slope, and it's always rise over run, right? The y over the x, not the other way around. That'll get you goofed up stuff. It'll flip these guys. So for this pattern, for instance, if I start 0, 5, and I know somewhere along in my pattern later I have 4, 7. First of all, our b value is 5, right? Wherever we start is 5. And this one started on 0, so it's 0, 5. That's going to be our b. Very easy. They gave it to us for free. So we know that this equation is going to have 5 for b. The relationship between x and y is what goes here, right? That's what slope is, right? How much we're going up for both of these guys. So Jordan, how much am I going up for the x? And then for the y, I'm obviously going up 2. And you figure out 2 because you can subtract, right? Subtraction is distance, right? That's what we're talking about here, distance. So our relationship is 4 over 2. As y goes up 2, sorry, let me say it again. 2 over 4. As y goes up 2, x goes up 4. And that's the equation that represents this pattern. You can keep following that pattern and you'd figure out what's next. So if I wanted to know what happens at, I don't know, 8, I could do a couple things. One, I could say, well, I increased by 4 again, so I'm going to increase by 2 again. 9, right? Or I could look at the equation that describes that pattern and plug in 8 for x and see what happens. 2 over 4 is just half, right? Another way to write that is half. So half of 8 is what we're doing. Half times 8 is just half of 8, which is 4, right? 4 plus 5, 9. Right? This represents all the possible patterns, or all the possible steps in our pattern. Now, we said earlier, 2 over 4 is just a half, right? So does this represent the same pattern? Question mark, right? Yes, question mark? This one, every time I go up 4 for the x, I go up 2 for the y, right? This one's saying every time I go up 1 for the y, I go up 2 for the x. Let's mess around with that. Let's see if we get the same pattern that pops up. So for this one, is it plus 5? Versus y equals 2/4 x plus 5. Well, the pattern always starts on 0, right? And where are we starting our pattern this time? 5, right? Same for both. That's the b value. Let's do that in blue, right? So we start on 0, 5. And that makes sense. If you were to plug in 0, what would you get? 0 times anything is 0. Plus 5 is 5, right? Really nice. Hey, Leah. We're trying to figure out if these two represent the same pattern. Because we do know a half and 2 over 4 is the same thing. And remember, 2 over 4 is we go up 2 for y, 4 for x, and that's our pattern after starting on 5. So if we follow this pattern, one way is to add a half every time, right? You could just add a half, right? X goes up 1, we add a half. X goes up another 1, we add another half, right? But that gets us weird numbers. So we said it's a lot nicer the other day to instead think of this as 1 in the y direction for every 2 in the x direction, right? It's telling you the relationship between x and y. And if you follow it that way, instead of adding up 1 and then adding on a half, you get nice numbers. You get 2, and you get 6. If we keep following that pattern, we'd add 2 again. We get 4. We add 1. We get 7. Follow that some more. Add 2 again. We'd get 6. Add 1. We'd get 8. Add 2. We get 8. Add 1. We get 9. Missed one. There we go. Now I'll bring up the black pen. That's our pattern. Is this the same pattern as this? Let's follow that out. We're not going to go up by 1. We're going to go up by 2 on the y side. We're going to go up by how much on the x side? 4. Good luck today, kids. Jordan's not waiting for any of you. So what do we get? We get 4 here. We get 7 there. Keep going. We add 4 again. 8. We add 2 again. We get 9. What do you notice about these patterns? Pattern A and pattern B? It's kind of the same, right? Like, notice we have 8 and 9 here, 8 and 9 there. We have 4 and 7 here, 4 and 7 there. 0 and 5, 0 and 5, right? It's cutting out the middle parts. That's all. So it's the same idea. What if we took these more literally, right? Because we said, remember, you can add 1 and add 2, or you can add 1 and then add a half, right? Right? So if we took those more literally, the other way of looking at these is saying, and it's kind of gross, right? We start out with 0, 5. But now we're adding 1 every time because that's what we're going to do to make the pattern easy. It's not because of anything up here. We're just adding 1. And then we're going to add a half. But in fact, let's change that to black so you don't think that it's because of any numbers up here. We're just adding 1 because we're just trying to see what happens. And then we're going to take both these together. I'm going to think of that as a purple. We're adding a half every time, right? That's our slope. If you notice, first off, we get 1, 2, 3 from adding this. Over here, we get 5.5, 6, 6.5. And if you check, 2, 6, and 0, 5 are what happens, right? So it covers the same numbers. It's just hitting the in-between parts more. That's all it is. It's just 2 different ways of looking at it. If we were to add 2 quarters here, well, 2 quarters is the same as a half. We're going to get the same results, right? Kaylee, I sent you a message. It was supposed to be 12:57. It's okay. I marked you here. I did, right? And that's everybody, I think? Yep, that's everyone. So they do represent the same thing. Why? Why are 2 quarters and 1/2 the same? Why? They're the same what? That's true. Right? As we add on a half, it's the same as adding on 2 quarters. It ends up being the same. What is a half? What's the idea of a half? A half is the same thing as a quarter? Same thing as 2 quarters, right? So you guys were probably taught something like this. Like, here's a whole, right? They keep using this word, whole. And half, this idea right here, is this much. Right? Because you take one piece and you divide it in 2. That's their idea. Right? This is saying you take one piece and divide it by 4, and you want 2 of the pieces. So we divide it into 4 pieces. Let's use something other than... So now we have 4 pieces. 1, 2, 3, 4, right? And we take 2 of them. 1, 2. See how they're the same? And they show you this because they think like this is really useful. And it is, because when you're dealing with fractions outside of school, almost always, and I think part of it's because, you know, that's the way we teach you, and so you never realize you're dealing with fractions even if you're not. But the way you deal with it is like chocolate bars, or, you know, proportions for a meal, right? How much? We have 1 turkey and everybody gets a quarter of it or something, right? And this is fine, but it's not really the full story. It's kind of like when we taught you subtraction was taking stuff away, right? And that works, right? You got 4 pens, you take away 2. How much do you have left? That's 4 minus 2, right? But now I've got 4 pens, and I'm minusing negative 2. Uh-oh. I mean, like, we're taking away a takeaway, so it's like we took away 2 before, but now we're taking away that we took it away. You know what I mean? You can make it work, but we're really starting to put pressure on this metaphor, right? It's really starting to fall apart at the seams. It's not really working anymore. You know, it's like when somebody's talking, it's like, oh yeah, it's just like when you do this, and it's, you know, just the same thing. And you're like, wait, what? What do you mean? Like, going to school is just like rowing a boat. And you're like, what? Like, oh, because, you know, like, you go when you row a boat, and you go to school, you go. And it's like, okay, I guess. I mean, you know, it's not a very good metaphor. And I think taking away is pretty bad metaphor for subtraction, because it falls apart pretty quick. And I think this is kind of a bad metaphor for fractions. What about negative fractions? Right? What about fractions of fractions? What does this mean? We divide it into 4 pieces and we take 2/3 of them? I guess, sort of. It's kind of weird. It's hard to visualize. And whether that works or not doesn't really matter. If it's hard to visualize, it's not a very useful metaphor, right? I might tell you something that's 100% true, but the metaphor is something you never heard of, right? Are you a big hockey fan? Awesome. So if I tell you that getting an A is like scoring a hat trick, do you have any idea what I'm talking about? You have no freaking clue, right? The metaphor can be true, but it's not very useful, right? Oh, we take 4 pieces, right? Oh, 4 pieces, and we take 2/3 of them. I mean, maybe, but that doesn't really help me out, right? So it's not a very good metaphor. Here's what I want you to do when you see fractions. I want you to think about relationships. Relationships. And we've seen that already. We've seen that one way to think about this fraction here is it's the relationship between x and y. As x goes up by 2, y goes up by 1, right? And sure, we can think of it as fractions, right? We can do this, that's fine, right? Always add a half. That's what you can think of, right? Always add a half. But it's kind of messy. And I think you've done that enough by now, right? You've had fractions since 5th grade. I think we should just try thinking about it differently for a second. Maybe you'll like it. Because everybody hates fractions, right? Couldn't hurt to think about it differently. Worst case scenario, you hate that too. Great, awesome. We're in the same spot we were before. So here's how I want you to think about it. When you see division, I don't want you to think, I have 4 pens and I divide them in half. I have 4 friends and 4 pens but 2 friends, so we each get 2, right? That's fine, it works, but then you get negative numbers, you get fractions of fractions, and it breaks down. What I want you to think about is relationships. So what do I mean by that? What's 1's relationship with 2? See division sign? When I see division, I think relationship. 1 relates to 2. How does 1 relate to 2? Right next to each other in the number line, aren't they? Right? What else do they have in relationship? Ooh, you can add 1 to get 2. Do you see there's lots of relationships between 1 and 2? 1 and 2 is a bad example. There's too many things going on. Too many things it could be. Let's use a different example. How about 3 and 6? We know that's the same thing as 5/10, yeah? Right? So less coincidences with this example, right? It's not that we add 1, right? Because that's the same as that. So 3 and 6, how are they related? You can double it, right? You can add it to itself. You can double it. So the relationship here is double. Oops. What's the relationship here? So the relationship between 3 and 6 is the same as the relationship between 5 and 10. Wouldn't you agree? 3 and 6 has a relationship of double. 5 and 10 has a relationship of double. Now, how come this is not true? How come we know that it's not equal to that? The relationship between here is double. What's the relationship here? Huh? Right, but what's another way to think of it? You can double 3 to get to 6. You don't double 10 to get to 5, right? What do you do? Right? These two would be equal. What about this? Not equal, right? Relationship is double. What's the relationship here? What do you got to do to 12 to make it 6? Don't say add or subtract, because that changes with the numbers, right? Here it was both double. You divide, don't you? We have it. You can either think of it as dividing by 2 or timesing by a half. Okay? Either way, that works. It's a different relationship, right? This is times 2. That's divide by 2. They're not going to be the same. However, is this the same? Yeah, they both have a relationship of divide by 2, yeah? Cut in half. So it's true. That's why they're equal. Their relationships are the same. That's what division means. Are the numbers the same? No. Right? The simplest representation of this relationship, for every 6, you have 3 of the other. For every 10, you have 5 of the other. For every 1, or for every 2, you have 1 of the other. We could simplify this to 2, right? 2 over 1. That's why we call it simplifying, because the relationship between 2 and 1 is the simplest relationship you can have. Because 4 and 2 is really just the same relationship as 2 and 1, right? Twice as many. You could write 4 to 2, you could write 5 to 10 to 5, you could write 100 to 50, right? At the end of the day, the relationship is 2 versus 1, right? Double versus original. So that's why we call it simplified, because this is the simplest version of that relationship. 2 versus 1. So division is just about relationships. Now, I mentioned earlier, this is kind of just an aside, that you could divide by 2 or times by a half. Do you know why that works? Talk about multiplication for a second. Just for a second, okay? Five groups of 2, 2 groups of 5. That's one way to think about it. I want you to think of the word of. That's what that means. 5 of 2. So there's 2. There's 2. There's 2. There's 2. There's 2. And I have 5 of them, right? Five groups of 2. 3/4 groups of 12. Oh no. Right? Do you see how that breaks down? And you're like, that's not very helpful. But of 3/4 of 12. I'll make it easier. A half group of 12. Okay, we sort of, kind of, right? You can kind of imagine what that is. Really what we're saying is half of 12. What's half of 12? Of course it is. Oh my gosh, duh. You don't need to be like, okay, well, I do this, and over 1, and then I go across, and then this, and then 2. That's 6. Oh my gosh, right? Come on. Waste of time. Half of 12. Well, how do you find half of a number? You divide it by 2, don't you? You get the same thing. A third of 12 is like that. You could also write it like this. What's a third of 12? Apply 3. 3, 6, 12. I want you to say it out loud so you can hear it slowly. 3, 6. You were so convinced. You're like, yep, 3, 6, 12. Yep. You say it 3 times. 4, 8, 12, right? Yeah, so it's going to be 4. No, it's okay. It happens. Right? Making that mistake doesn't make you a bad mathematician. It just means you made a mistake. You counted wrong. Right? You had the right idea, right? I need to add up to 12 3 times, right, with the same number, right? You just counted wrong. So yeah, 4, right? A third of 12 is 4. 12 divided by 3 is 4. Same thing. Now what happens if we get here? This was our question before. If I tell you I have 3 chickens, how many chickens do I have? If I tell you I have 3 quarters, how many quarters do I have? 3, right? This is 3 quarters. Got it? Now I bet you know what 1 quarter is. What's a quarter of 12? I'm giving it to you. 3, right? Ooh, we got 9s in the chat. If 1 quarter is 3, what would 2 quarters be? Nope, hold on. I'm asking a different question. I'm throwing you off. If 1 quarter gets you 3, 2 quarters would get you. Don't you listen to them. 1 quarter gets you 3, right? So if I double that, now I've got 2 quarters, right? What's 2 quarters gonna get you? 6, right? Twice as much, right? 1 chicken gets me 3 eggs, right? 2 chickens are gonna get me 6 eggs. How many? 3 chickens are gonna get me 9 eggs. 3 quarters of 12 is 9, because 1 quarter is 3, and this is 3 times bigger, right? 1 quarter times it by 3, you got 3 more. So you have 9. Another way to think of that is if I had 3 times 12, you tell me 36, right? What if I told you to divide that by 4? 36 divided by 4. What's 40 divided by 4? Rough day for you. 10, right? What's 36 divided by 4 then? Yeah, it has to be, right? Because 40 divided by 4 is 10. So 4 less is going to be 9, right? So that means 36 divided by 4 is 9, yeah? Yeah. 3 quarters of 12. This is the exact same thing as this, is the exact same thing as this, is the exact same thing as this. They're all the same. So it doesn't matter whether you times by 3 and then divide by 4 later, or if you do 3 quarters times 12. 3 quarters times 12 is kind of a hard problem. Times by 3 divided by 4, not so bad. What if we did this? What if we divided by 4 first? What's 12 divided by 4? $12 divided by 4? Oh, I've broken her brain. I've asked her 12 divided by 4 and 12 divided by 3 so much she's confusing them all. I got you to say 2 once, so that's kind of cool. 12 divided by 4. Well, half of 4, or half of 12 is 6, right? There you go. It's okay. So this got us 3. And then we still have the times by 3, yeah? It doesn't matter what order you do it in, does it? So you can times by the top and get 36 and divide by 4 and get your answer. You can divide by the bottom first, get 3, times by 3 again and get your answer. You can do 3/4 of 12, which if you know it, and it's a good day, right, then you'll get it. Because it's 1/4 of 12, but times 3. 1/4 of 12, and then times 3. Cool? Right. So let's get back to division. Relationships. Relationships. So when we see something like this, it's telling us our pattern begins on 2, 0, 2, right? And you can check that, right? Always check it, because sometimes you'll say 2, 0. Right, if I plug in 0 for x, I get 2 for y, yeah? Okay, we didn't goof. We didn't goof. If I plugged in 2 for x, I'd get 10/9 plus 2. That's not right, right? It's not going to get me 0, right? 0 goes with the x. And this number represents a relationship between 5 and 9. Whoops, I goofed that up. 9 is... Oh, no, I didn't. No, I didn't. No, I didn't. I'm having just as much trouble as Jordan today. 5 is how much we go in the y direction, right? Because it's rise over run. So we're going to get 9, 7. It's the relationship between the numbers. That's it. And that's our line. We could graph that. 0, 2. That's here. And then 9, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. So here. And there's our line. It's going to have all the values that are related like this. So I've given you the equation, and you're able to find the pattern. What if I give you a pattern, and you find the equation? Right? I think that's the next question. No, we'll keep it simple. We'll start out simple. Obviously, there's more to this pattern, right? I could keep going. I could do in between, right? But I gave you that. What's the equation that's going to represent that pattern? First of all, where's our equation start? Our pattern start? 3, because 0 is where we start, right? And 3 is the number, so we get 3. Whoops. Ah, where's my black pen? There we go. Can't even tell. Now, how do we figure out this number? Remember, it's about the relationship between x and y, how much they increase by. 5/9, because this is 5. And again, we do the y value first. It's kind of weird, but we do. Rise over run. And there you go. Ta-da. That's it. Now, you will be asked by other math classes. They'll say, okay, here's the problem. They say, given 2 points, you're given 0, 3, and you're given 9, 7. I want you to find the equation of the given line. And what they're asking is the exact same thing they did here. Oh, whoops, 8. Now it's the exact same thing they were asking. And what they'll tell you to do is they'll tell you, oh, child, dear child, you need to use slope formula. And you're like, slope formula? What's that? And they'll tell you this. Division means what? The R word. Good job, Cameron. Relationships, right? How they relate? Okay. And again, it's not what it means. It's just another way to think about it. I think I can be helpful. I'm not going to get mad at you if, you know. they'll say, oh, you need this, you need y2 minus y1 and x2 minus x1, and that is the formula, and you need to memorize that. And that's how you figure out what the slope is. That way you can plug it in here, and you can get the equation. And what you do is you go, oh, okay, I know what this is, right? We have, I'll let this be x1, and I'll have this be x number 2, because they're both x values, and I'll have this be a y value 1 and y value 2, and then I plug all the stuff in, and y2 is 8, and I remember to write it in parentheses because this is important, and then subtract y1. Well, y1 is 3, so I wrap that in parentheses, and there's the 3, and then there's a division bar. I remember that because I memorized the formula, and there's the division sign. Then I take out the thing, and then x2 is 9, and I write that here. Don't screw up the order. If you screw up the order, it changes everything. And then if I do this, it's subtraction, and then I finally subtract 0, and I write that down, and then I do the math, and I get 8 minus 3 is 5, and 9 minus 0 is, aha! 5/9. I did it. And hopefully I didn't goof these or forget to subtract and add instead. And it's fine. It works. If you do it right, you don't screw it up. But you have no idea what this means. Slope is rise over run. It's how much the y goes up and how much the x goes up, right? It's the distance. We've talked about this. That's what this is. The distance between 0 and 9, right? Distance between 3 and 8. 9/5, or 5/9, sorry. I always screw them up. That's what this would be. I don't even need to do the math. Knowing what it means can save you a lot of time. All this is saying is how much the y changes. Right? Changes delta. And how much the x changes. If x goes up by 1, how much does y go up by? If x goes up by 9, how much does y go up by? Well, according to this, as x goes up by 9, y goes up by 5, right? In other words, this is your rise, how much your y changes, and your run, how much your x changes, right? Horizontal. It's a pretty easy problem if you know what you're doing. Let's make it a little bit harder. It was easy because I know that this is 3, and then I just got to plug in 5/9 here and I win, right? Let's try something a little bit crazier. Given the 2 points, find the equation of the line. Now, don't be fooled. We got to say that 3 goes here because it was 0, 3, right? This is 2, 1. We don't get to put a 1 down, right? Let's not worry about that. Let's worry about the relationship between x and y first. I didn't write it underneath, so I'm going to go this way. How much did I move from 2 to 5? Right? So our slope has to have 3 for the run. What about the rise? Gross looking slope. But again, it's only gross if you think fractions, right? 7/3. Ew. 7 and 3, their relationship? Okay. Sure. No big deal. One goes up by 7, the other goes up by 3. Not scary. Now, how do we find the b? There's a b? We have to find where the pattern starts. So remember, this is supposed to represent, when we're done with it, we're not done, we still got to find the b. It's supposed to represent this pattern, right? And we want to know where the pattern starts. So we want to know where 0, what goes here, right? Right? Before they gave us 0, 3, and we're like, yay, 3 goes there. Now we want to figure out what goes here. So how would we figure out what goes there? That's tough. Well, 2 should get us 1, right? That's the idea, right? 2 and 1 go together. If x is 2, this is telling us y will be 1. Okay. So if I make my x 2, I need y to be 1, right? That's what I should get. 2 and 1 should get me, right? 2 should get me 1. Now, right now, I think you can tell very easily. If I double this, right, it's 14 thirds instead of 7 thirds. That makes sense, right? 2 of 7 thirds. Well, 2 7 thirds will be 14 thirds. 2 of 7 chickens is 14 chickens, right? Ugh. Well, B's not 0, I'll tell you that much, right? But it's whatever number gets this to be 1. We're going to have to subtract something, right? That's bigger than 1. If this was 3 thirds, we win, right? So I need to take how many thirds away to make that 3 thirds? If I take away 1 away, I get 13 thirds. Say again? If I do math and I get 3 over 3, I win, right? Because 3 over 3 is 1, right? So how do I make that go from 14 over 3 to 3 over 3? Yeah. I've got 14 chickens. I need to take away 11 chickens to get 3 chickens. So this must be what this has to be. Right? Something plus a number gets us 1. Well, we're going to have to do a negative number, right? Because it's already too big. So it's 11. Just think about it. So our equation's kind of gross. I don't know. It works. I wouldn't want to map all out the points, all right? That's going to be gross, right? I don't have a problem starting on 11 thirds. It's not too bad. And then I add 7 and add 3 every time. So 3, add 7 to that. Not very fun. Question. How many thirds are in the number 1? How many thirds are in 1? How many thirds are in the number 1? 3 thirds, right? How many thirds are in the number 2? How many thirds are in 2? 1. Why 1? It's okay, it's okay. Why 1? I'm interested in why you thought that. It's not right, but why did you think it? Not sure? Okay. Cameron's right at 6, right? 6 of them makes 2. How many thirds in 3? 9. Right, that's what this pattern says. It's gross. How many thirds are we adding here? How many thirds are in the number 7? There's 9 thirds in 3. How many thirds are in 7? 14. You're thinking. You're thinking. I'll give you some time. Although you say 14, you're like, oh no, that can't be it. Your mouth is faster than your brain. Yeah, right. That's okay. This is an easy question. What divided by 3 is 7? If I'd asked you that last year, before you met me, you would have gone on autopilot. You would have been like, okay, 21. I know 3 times 7 is 20, right? But because I'm making you think about it differently, it becomes harder, right? Because you have to think about it in a different way. It's like your brain's taking a different path to get there. That's what I try to do. Take some magic to do it, but I'm pretty good at making your brain think the direction I want it to think in. It was 21. So really we're not adding 7. We're adding 21 thirds. If I've got 21 thirds and we're taking away 11 thirds, how many thirds do I have left over? 21 thirds minus 11 thirds is... Jordan's brain's burned out. So somebody take the opportunity. 21 thirds minus 11 thirds. See if you can beat her. right? Because that 7 is just another way of writing 21/3, right? They're the same. 21/3 minus 11/3 is close. Why 10? Yeah. It's 21 chickens minus 11 chickens. Doesn't matter what thirds, quarters, fifths. Chickens and chickens. Ta-da! Kind of gross, but we can do it. Right? Kind of gross, but we can do it. Let's give you another one. Doesn't tell us where we start, right? We didn't get that for free. We didn't get 0, comma, whatever. But let's find the relationship between these numbers. First of all, how much are we changing in the y direction? 1, but which way are we going? Down, right? -1. Which way are we going in the x direction? We're going up. How much? Ooh, 7, right? It's got to be, because 6 and 6 is 12, so 5 and 7. Yeah, good reasoning. So that must be our relationship that's going on here. Every time this guy goes down by 7, or sorry, goes up by 7, this guy goes down by 1, right? Okay. So now we need to figure out b. Well, 5 should get you 9 if we set it up correctly, right? If we do the formula right after we get b, 5 here should get you 9 there, right? So in order to figure out what it has to be, I can just plug in these numbers, right? Because I know 5 should get 9. The question is, what does this have to be to make it that way? We can divide by the bottom or times by the top. What do you want to do? The top. So we get this, right? And that makes sense. If I have 1/7 and then I times it by 5, now I have 5/7. Also, it's negative, right? So the question is, what do we have to add to this to get 9? We should probably think in terms of sevenths, right? To make it easier. So something minus 5 is going to get us 9. But remember, we're thinking in terms of sevens, right? If we wanted to get 1, we'd have to do 12 sevenths minus 5, because that would give us 7 sevenths, right? How many sevenths do we really want? How many sevenths are in the number 9? Well, there's 7 sevenths in 1, 14 sevenths in 2. How many sevenths are there in 9? 68? Why 68? Well, there's 70 sevenths in 7, right? I'm sorry, 70 sevenths in 10. $60 something, right? Got a guess? Remember, this is also division. What divided by 7 is 9? Oh, I get what you're saying. So he's saying 63. Check this out, Jordan. We're asking, what do we need to do to get 9? Another way of asking that is, what do we need to do to get this? Because 63 divided by 7 is 9, right? Trust me on that? Right? 7 times 9 is 63. Trust me. 7 times 10 would be 70, right? So 7 less would be 63. Okay. And why is this an easier question? Because I'm asking, something minus 5 is 63, because they're all sevenths now, right? What minus 5 gets me 63? Well, he's saying 68. Anyway, we'll talk more about this tomorrow. Your brain hurt a little bit? Mine too. It means we're thinking. I'll see you guys later. Take care. I gotta go to 7th hour. Take care.